So activity 2.2 has us pick up where we left off with in activity 2.1 with negative and fractional exponents. So just to refresh our memories, we'll take a look at problems 1 and 2. Problem 1, we're supposed to evaluate the expression first by rewriting with positive exponents only. Alright, so let's, this 2 raised to the negative 3, recall to handle the negative exponent, we take the reciprocal of the base. So my base is 2, so I'm going to write 1 over 2, and then make my exponent positive. So you can see here's my 1 over 2, my exponent's now positive, so 2 raised to the third power is 8. So now my final answer would be 1 over 8. When I look at number 2, my base is 2/3, so I'm going to take the reciprocal of 2/3, which would be 3/2, and then make my exponent positive. So here's my 3/2 written as a reciprocal of 2/3. My exponent now becomes positive, so we're left with 3 raised to the second, which is 9, and 2 raised to the second power, which is 4. And that's my final answer. So let's continue. Maybe you want to press pause on your screen and try and complete problems 4 through 6, or really just 4 and 6. Problem 4, my exponent is affecting the denominator, so I'm going to take the reciprocal of this a, or 1 over a, and rewrite this as a over 1. Or think of it as, if the exponent is negative in the denominator, just move the base to the numerator and make the exponent positive. So you can now see we're left with a over 1, and then I make the exponent positive, so I'm left with a cubed. Problem 6, well, the negative 4, there's no exponent touching the negative 4, so the negative 4 will stay on top. But the b is on the denominator and is being affected by this negative exponent. So we're going to move the b to the numerator and make the exponent positive. So you'll notice the negative 4 stays where it is. The b comes up and becomes a positive 3 for the exponent. So we're left with negative 4b cubed. And that's my final answer. So the next section, it says we're going to apply properties of exponents to expressions with negative exponents. So in the previous lesson, we learned, I think, 6 properties of exponents: multiplication property, the division property, the product to a power property. We're going to combine all of the properties we've learned to answer some, I guess, more challenging types of exponent problems, specifically ones with negative exponents. So let's look at the practice problems. We're going to tackle problems 8 through 16 even. So problem 8, we have x to the negative 3 over x to the negative 5. So we have a couple of options here. We could simply bring the x to the negative 5 to the top and make that exponent positive. Bring the x to the negative 3 to the bottom and make that exponent positive. Or we could do the math, x to the negative 3 minus negative 5, and simplify. I chose to handle the problem in this fashion. Right? I bring the x to the negative 5 up and make the exponent positive. The x to the negative 3 I brought down and made the exponent positive. And then we're left with x to the 5 over x to the third. So you subtract 5 minus 3 to get positive 2. So my final answer is x squared. If I look at number 10, okay, well, the y to the positive 4 in the denominator, that stays where it is. And we simply bring the y to the negative 4 down. So here's my y to the 4, and then I bring the y to the negative 4 down, make it positive. And then we use the multiplication property, where we have the same base. We add the exponents to get positive 8. So we're left with 1 over y to the positive 8. Let's take a look at number 12. So number 12, the w squared, that's a positive exponent. So I'm going to leave that where it is. The w to the negative 3 I'm going to bring down to the denominator and make the 3 positive. The w to the negative 4 in the denominator, I'm going to bring up to the numerator and make the negative 4 positive. So you can see the w squared stays where it is. The w to the negative 4 comes up top. We make the exponent positive. And the w to the negative 3 comes down, and we make the exponent positive. And then again, we use the multiplication property. Same base, we add the exponents. 2 plus 4 gives me my 6. And then we use the division property. Right, w to the 6 over w to the third. We subtract 6 minus 3 to get 3, and w cubed is my final answer. Let's try problem 14. So in 14, I'm going to have these 3x to the fifth times x to the negative 3. Well, we have the same base, so I'm going to add the exponents, right? The 3, I'm going to leave 3 by itself. But the x to the 5 and x to the negative 3, if I add these exponents, I get x to the positive 2, right? Because 5 plus a negative 3 is positive 2. So we're left with 3x squared. So for number 16, all right, so the 2 and the negative 10 we can combine. We'll call that negative 20. The x to the 5 and x to the negative 8, well, if I add 5 plus negative 8, that will leave me with negative 3. So I should have negative 20, x to the negative 3, and then this y to the negative 3 just stays where it is. So that's going to look something like this. Okay, so we have the 2 times negative 10. There's my negative 20. X to the 5 times x to the negative 8. There's my x to the negative 3, because 5 plus negative 8 is negative 3. And the y to the negative 3 just stays where it is. But I like my answer to be written without negative exponents, so I'm going to bring the x to the negative 3 to the denominator and make it positive. I'm going to bring the y to the negative 3 to the denominator and make the negative 3 positive as well. So my final answer is negative 20 over x cubed y cubed. Number 18. So everything that's inside the parentheses will need to be squared. So think of this as negative 3 raised to the second power. So that's negative 3 times negative 3, which gives us positive 9. Now the product to a power rule says that we can multiply the exponents. So this a to the negative 5 becomes a to the negative 5 times 2, which is negative 10. And we have b to the positive 6 times 2, which would give me b to the positive 12. So again, here's my negative 3 squared, that's positive 9. My a to the negative 5, remember we multiply the negative 5 by 2 to get negative 10, and we multiply the 6 times 2 to get 12. So far we're looking good, but this negative 10, I want to get rid of the negative exponent, so I bring the a to the denominator and make the exponent positive. And that's my final answer. Next, we're going to try roots and radical notation. So let's take a look at a few of the book's examples. We say that 5 is the square root of 25 because 5 times 5 is 25, right? So when I have the square root of a number, I'm really asking myself, what number multiplied by itself will give me the number under the radical sign? So we can say that the square root of 144 is 12 because 12 squared, or 12 times 12, is 144. Okay. If I put a negative outside of the radical sign, we can say the square root of 25 is still 5, and then we have the negative sign outside, so we'd be left with negative 5. You could even say that this negative square root of 25 is really saying the opposite of the square root of 25. So again, the square root of 25 is positive 5, so the opposite of positive 5 would be negative 5. When you look at example 3, the square root of negative 25 is not a real number because there's no real number that I can square to get negative 25. Right? If I do 5 times 5, I end up with a positive 25. If I were to square a negative 5, I'd have negative 5 times negative 5, which is also positive 25. So there is no real answer for example 3. So we've just talked about the square root, but what about the cube root? So instead of a 2 in this index, by the way, if there's nothing inside this index, it's assumed it's a 2. But if I were to place a 3, now we're talking about the cube root. So what we're really asking here is the cube root of 8. We're asking what number multiplied by itself 3 times would give me 8. Well, 2 cubed is 8, so the cube root of 8 is 2. And we can keep going, right? We have the square root, the cube root. If I were to ask you about the fourth root, well, now I'd put a 4 in the index. So the fourth root of 16, well, we're asking what number multiplied by itself 4 times would give me 16. So 2 times 2 times 2 times 2 is 16, right? Or 2 to the 4th is 16. So the fourth root of 16 would be 2. let's take a look at a few of these practice problems. Right? When I look at problem 20, we're taking the cube root of 27. So we're asking, what number multiplied by itself 3 times will give me 27? I think it would be 3, right? 3 times 3 times 3 is 27. So here's my answer, right? The cube root of 27 is going to equal 3. Again, because 3 multiplied by itself 3 times will give me 27. When I look at number 22, the answer is going to be not real, because I can't think of a number I can multiply by itself 2 times to give me negative 36. Right? This is saying the square root of negative 36. Again, if there's nothing written in the index, we assume it's a 2. Right? So here we see the 3, we see the 4, but if there's nothing in the index, we assume it's a 2. And there's no number I can multiply by itself twice to give me negative 36. So the answer here would be not real. For number 24, we're asking ourselves, what number multiplied by itself 4 times will give me 16? Well, I think the answer would be 2. If I were to multiply 2 times 2 times 2 times 2, right, we do that 4 times, I get 16. So 2 would be my answer.